I've had a few requests from people to see what it looks like when I'm drawing patterns out of the sand, so this will be a little demonstration of that. What we've got is a mold that's split apart. Here's the cope that I took off earlier, and I removed these riser patterns and the sprue pattern with a spot for the filter to go in. Anyways, let's go ahead and draw out these patterns here and see how that goes. Since these patterns have letters on them, I can't shake them side to side very much or I'll break off the letters. So I just tap just a little bit on, hoping that loosens the bond of the sand to the pattern. And then I use this bar so I can draw this out uniformly. Otherwise I'm either pulling on this side or pulling on that side, and it tends to come out wonky. But this way I can hold on right here, keep up pressure, just slightly tap, and out it comes. So here's the pattern that I was talking about, and those letters would break off if I didn't avoid shaking that pattern side to side, as you often see done with many patterns. Just doesn't work here. So let's go ahead and do the other one as well. These are plastic 3D printed patterns, filament printed, and what I found is insetting wood plugs here makes for a very good attachment point. Otherwise the plastic tends to crack out because it doesn't have a lot of local strength. I guess I could, especially 3D print in details to do that, but it's just very easy to print a hole in the pattern and then just plug it with a wood dowel that I have. Let's do the same thing here. We'll tap down on the pattern just a little bit to induce a little vibration, and then we'll just lightly tap up, and out it comes. And this one drew cleanly as well. You can see there's no residual sand, so those letters will look nice. Out the down screw pattern. This I can wiggle around. I doubt if you can see it from there, but there actually is a little wiggle room now, so that one just comes out really easily. I have a ceramic filter here that I'll put in place right like so after I blow all the dust and debris out of here. What I'm doing right now, that you can't see, unfortunately, is carving in little recesses at the very end of the cavity there, in hopes that any possible sand that might break loose traveling into the mold will end up in a little trap down there. There is a passage down the sprue, and I did carve away sand when I had split apart the cheek and the drag. I had carved a channel for the metal to get from here to here, and that's what I'm blowing out right now. You might actually be able to see the channel. I'll move the camera a little bit here and let you see some of these details. I'm also going to make vent holes in the cope here to let gases that develop when the metal hits the mold, and lets those gases out and lets the mold fill easily. I'm just poking all the way through to the top. And then I have a little fine poker as well. I just make a couple little pokes down here. This is a system that has worked out pretty well for me in the past. It's good filling, but I think it's a good idea to make those nests. I'll move the camera now so that you can see into the mold. And I think you can probably see the letters pretty well, and then the little feather logo. Here's the channel that I was talking about that connects to the down sprue here that lets the metal go into each of the cavities. Now it's time to reassemble the cope on the cheek there. You can see that I have put the ceramic filter in place, and that filter intercepts any garbage that might end up in the iron stream. There really shouldn't be much there in the first place, but just in case, that ceramic filter will filter it out. And this is a little closer look at the filter. You can see that it is a honeycomb consistency and is made of silicon carbide to provide excellent heat resistance. It has to be very, very resistant to heat because of the iron reactivity and temperature. So let's take a look down in the mold in a way that you couldn't previously see, so that I can show you where the recesses were that I was cutting and what the letters look like in the sand. Shining a light sideways like this tangentially really helps things stand out a little better. And down in that corner there, that's the little recess that's supposed to catch any sand that might get swept along in the iron stream. Here is the entry point that I was referring to. I don't think you could see before. That entry point allows the iron that has passed down through this filter, down through the sprue, through a channel cut on the surface of the drag, and then out into the mold cavity. And there's one of those, of course, on each side. So what I'm going to do next is I'll put some wedges on the cheek here that'll allow me to pretty closely set the cope down, but give me a little bit of time to wiggle around and get the pins that need to line up with these holes. There's a couple of pins on the cope that line up with those holes. I'll try to show you one. There's one of the pins right there, and here's another one down here. Those pins lock everything together so that the cope doesn't come down in an odd position on the cheek, and it prevents any motion this way and this way, and registers things accurately. So I'll have to move the camera now back. I can't hold the camera and reassemble the mold here. The wedges do allow me a chance to set this down more carefully and more accurately than if I just tried to hit it. Some of the time I can just hit it, but I found that the wedges are a lot better way for me to go. This portion of the mold probably weighs something on the order of 20 pounds. The whole works weighs about 70 pounds. There, those pins are locked in. You can see that that's holding things nicely. There's still the wedge in back that I'll take out and press down firmly to make sure that the coat is nicely seated on the cheek. If there's any gap there, the iron will run right out and have a mess. The whole thing is spoiled. So now we'll go ahead and put these screws in, which lock the coat to the cheek. Got one on each side.